Okay, folks, let's go ahead and zone in to a lecture on inheritance. And so, as my lectures have been going, there's a slide deck, and I use that as a general reference, but I also just like to, I don't know, if I can, explain like I'm 5, right? And just kind of go over what's needed to get going. Right, so I'm going to try and just go over the fundamentals of inheritance, why we use it, and just some real basics for this first lecture. And if I can, we'll keep it short. We'll see if I'm never good at that. I always say we'll make it a short one and an hour and a half later, but I'll try and keep it short. And so, the last couple of topics you heard the same reasoning why it's important. And so the last couple of topics have been methods. We took a couple of chapters on the fundamentals of methods. And methods are used across programming languages going back, to the beginning of coding. And so a method is a block of code that you could call repeatedly and it executes a task. And it's got inputs and it's got outputs. Okay, so methods, what do methods do for us? They allow us to create repeatable code that you can write once and execute many times, and hopefully you saw some of the benefits. And a method is a single block of code that's executable. And then we said, you could take methods and add in something, like data, and you take data and methods together, and you can make this reusable thing. It's not just a reusable block of code that executes a task, but now we've got reusable methods and we've got reusable data attributes, right? And you can kind of group these things together in what's called a class and create, from that class, you can create objects. And so if a method, the whole point is reusable code, it's the same point for classes and objects, reusable code, making these things reusable and efficient. And so that's been the point in the last month of this class, is writing reusable code. And that's really at the heart of what inheritance does for us. Inheritance keeps us from writing repeated code. And so, as an example of this, like at a very low level or very high level, I would say, like if we have a class called student and we have a class called teacher, like these are just, and we start thinking about what attributes would a student have, and pretty quickly you might come across, well, it's really important to have a student first name as an example, right? In which case you would have a public first name property with the get, which returns first name, and a set, the set's first name equal to value. Okay, and so using the arrow syntax, these are standard get and set blocks. Okay, and so what you find out pretty quick is when you start having classes and you start having many classes, well, would a teacher also not have these same things? Right? And the answer is, well, yeah, probably. You've got, and all of a sudden, what do you have? You've got repeated code. Okay? So inheritance comes in to save the day, and what we can do, and inheritance works in coding just like it works in the real world. In the real world, what do you inherit? Well, you inherit genes from your parents, as an example, right? And I always say, my father was tall and my mother is pale. Hello, here I am, a tall, pale guy, right? So I inherit those genetic traits from my parents, and it works in coding the same way. What you can do is you can define a parent class, and they're literally called parent-child relationships. You can define a parent class and have a child inherit from the parent. Okay? And so what does the child inherit? Well, everything that's non-private. Everything that's non-private is what the child will inherit. So instead of doing this and repeating it here, okay, so we'll just keep this real simple. What we could do is we could make a parent class, which, by the way, they inheritance, like if you're going to have a note, is typically known as an is-a relationship. And what this means, when you see this in the textbook, is that you define inheritance by what things are. And so you can inherit a child when a child is a something of a parent. And so I'll give an example. A teacher is a person, and a student is a person. And so the parent could be a person. You know, the parent class could be a person, right? So typically, well, not typically, when you look up the book definition of inheritance, they say is a relationship, which just means when you describe the child is described, the child is a relationship with the parent. A student is a person, and a teacher is a person. And so it's based on what the things are. Okay? Yes?
So you have a parent called Rankin, and then you have teacher and student.
Well, the parent wouldn't necessarily be Rankin, the parent would be person. Because, again, it has to be, this is a relationship. So you would say a student is a person, a teacher is a person. So where you would not say a student is a Rankin. Does that make sense? A student is not a school, in other words. So how you could go about getting rid of this repeated code when you've got these very common setters and getters and fields and things like that. Let's go ahead and make that person class. And let's just put this field and this property inside of person. Let's take that comment out. Okay, so now I've got this class that's going to be used as a parent. Well, how do we tell, now that we've got this teacher class, how do we inherit from person? And it's pretty simple in C#. You do this. You do :person. And so this says that a teacher is a person, in fact, that a teacher inherits from person. And what does that really mean? Well, it means that this teacher receives all of the non-private members of person. So what members are there? Well, there's a member, by the way, just as a reminder, a member is just, members are properties. So a property is considered a member. A method is considered a member. An attribute is considered a member. Like, these are that's a generic term for those things. So basically the different components of the class, if you will. And so what's non-private? Well, first, the property is non-private, but the instance field is private. So it works kind of in a funny way that through the public property, you can still set a field called first name. We've got this set block. In person, we create teacher. Now I'm not going to define anything unique. Like I'm not going to define anything in teacher, right? I'm just going to show you that because a teacher is a person, that if we create a teacher, that we have a first name property, right? So just to demonstrate the inheritance, if I were to go into this constructor of my form and I were to say teacher identifier Gudmestead is new teacher, that I could say Gudmestead dot, and there's my first name property. And this will have access. Now, why is that not working? Well, of course, I've got it as an int. Why is a first name an int? Did anyone else see that? I didn't. Okay. All right. Just let me go with this, okay? Yeah, right? All right, there we go. So now, well, there you go. And that's a lot. I mean, that's not all the theory that goes into this, but that's a lot of the theory, right? I was thinking about this the other day, just real quick, side note. I think part of the challenge of learning this class when you come in as a new student or a returning student, it doesn't matter. You got a lot to learn. You got Visual Studio to learn. You've got just all the different tools and debugging. There's a whole lot to learn in this class, kind of up front. But to be quite honest, I really feel like if you understood classes and objects, like the difficulty of learning inheritance is not as hard. It starts, in other words, if we've been going 50 miles an hour this entire semester, like we're going to back off to 40 this chapter. So hopefully you can take my word for that and believe me. But the important part is you got to have the foundations. Yeah.
So basically, you're saying like a person would have like a first name, last name, whatever, age. But if it was a student, they would have a student ID, and you can add a student ID like specifically to that.
It's exactly right. So what we've created here is a hierarchy. We've created a hierarchy. Above teacher and student is person. And so this hierarchy goes from general or generic. The higher up the hierarchy, the more generic things are. Like we would all, if you stop and think about it, a person is a more generic thing than a teacher. A teacher is a more specific thing than a person, right? So in this hierarchy, we go from generic up top to specific down below. And so inheritance, you can have underneath teacher, you can have something. So if you have a student teacher, for example, a student teacher is a teacher. And so I could make another class here. I could make another class called student teacher that inherits from teacher, and teacher inherits from person. So just like in the real world, my dad is tall, but he probably got that from his grandfather. You know what I mean? There's multiple levels of inheritance. And so the higher up the tree, the more generic the thing is. The lower in the tree, the more specific a thing is. And so to Josh's point, he says, hey, you might not put something like a student ID field inside of person because a person is too generic for a student ID. And so when you have these child classes, they define the specific members to that class. And so the general properties that you can say, okay, well, a person has a first name, a last name, a social security number, a person has all these important fields. Let's put the generic fields in person, but let's put the specific members in the children. So the lower you go, you have more specific members, more specific methods, more specific properties, more specific attributes. Does that make sense? Answer your question? Yes.
Okay, so 2 questions. So first one, in class student, why are we not inheriting person?
We should inherit. I didn't finish the job, but thank you.
Okay, so what's happening here is it already has all the private things from person, but it also has a specific.
Wait a minute. It has all the non-private things.
Okay.
The one trick around that, well, public first name, this is a property that references a private field. And so through this public property, you have access to the private field, but only through that public property.
Ooh, that's confusing.
It is. It is. In other words, you get access to this field, but not directly. Like there is no, if I go into my, like the first name property is capital F, right? But you're noticing I'm not going to be able to do Gudmestead._first name. In other words, I don't have access to this. This is not going to work.
You don't need to, though.
You don't need to. You have controlled access through the property. So, Vinny, to kind of go back to what you were saying, you have access to all the non-private fields.
Properties, right?
Members is the best way to describe it. Members are inclusive of attributes, fields, properties, methods, basically anything that's not private. Ryan?
So it's kind of like if you were to like want to like get like a on like a rug and like rub your feet on it and then get like static electricity.
Okay.
And then touch your friend.
All right.
He gets shocked, but if you're not touching the carpet, then he can't get the shock.
I'm not following, but
I get it.
all right.
It's like a chain. Like you need
Yeah,
to.
It's a
you
chain.
You have to touch one thing to be able to get the shock.
To get to, yeah, you have to inherit from something to get those things. Yep. Now another rule here, right? So inheritance is so it's defined based on what things are. That's one rule. Inheritance is based on what things are. That's why it's called an is a relationship. And in software engineering, one of the tasks is you're going to have all these paragraphs of, a written problem. You're going to have a written problem that you're trying to solve with an application. And in that written problem, you'll see the language, is a. And that's kind of an identifier of, hey, that might be an inheritance thing. Okay? Another relationship is a has a relationship. And you guys have been doing this in your labs where you've got, for an example, this is called aggregation, by the way. In your labs, an order has a soda, right? You guys did that where the order class has an instance field of soda. Okay? So has a relationship is when one object has another object as an instance field. So you've been doing this has a relationship without even, and that's just another, we're going to get into relationships when we start talking about inheritance. Inheritance is a relationship. The other rule, the second rule, you can only have one parent. Yeah, in the real world, we got two parents. That's just the way it works, right? You got a mom, you got a dad, you got two parents. And in some languages, you can have multiple parents. Okay? But that can cause issues when you have multiple parents. For example, what if we had one parent with this property, first name, and then we had a second parent with that same property? That's going to be a conflict. Okay, and so these conflicts, when you have multiple parents, cause problems in other languages. That C# fixes that, and they say, you know what, you can only have one parent.
You can only inherit one class.
Yeah, you can only inherit one class.
Okay.
All right, and so that's just a rule there. You can only have one parent. And that's why you got colon and then one thing here, and that's it. Now if I flesh out this example real quick, if I do public int student ID, get arrow underscore student ID, set student ID to value. I just want to show you that because student has a student ID, this is a more specific member for this class, that if I go into my form and I create a student object, I can set s1.firstName because that comes from person, and I can set the student ID, right? So students have student IDs. Well, of course, teachers do not. If I say Gudmested dot, there is no student ID here, right? Because that's a specific member of that class. It doesn't belong to teachers. It only belongs to students. Yep.
Just a quick review question. So is that get in set block that says like value it's inside a student? Is that getting is that pulling from like the form student ID equals 1? Like where is it getting where is student ID getting that data from?
The question is, where's student ID? We're setting it right here.
Okay, and so it's taking it from the form and putting it into.
Yeah, that's right. Yeah. Well, yeah. So this property puts the value of 1 into this value keyword, and therefore underscore student ID for that particular student is set to 1. Right? But these are called instance fields, so every student can have a unique student ID. Does that answer your question?
Yeah, I just get confused when like there's different variables for the same like.
Oh, I understand.
It
is confusing. Why do we have 4 variables that hold the same number? Like if you think of this, like we've got the number 1. This is coded into our source code, and so another name for this value of 1 is an integer literal. It's literally coded in, right? And then we put it into this first name property, so this number of 1 comes over here, and the number 1 value holds the number 1. And then ultimately we set it into, on student. So value here holds the number of 1. And then ultimately we put the number 1 here. So just that number 1 value is in like essentially 3 different, like if you're following the flow, it goes from a literal value into this keyword value into this instance field. So to say that, yeah, I have a hard time kind of following that flow, I get it. Breakpoints, breakpoints, breakpoints. They show you every step of the way. Okay. So I guess rule number 1 is a relationship. Rule number 2, you can only have one parent. All right. Rule number 3 deals with constructors. It's kind of a weird rule, so let's break it down a little bit. I don't have a constructor here, but there is a constructor. What constructor is provided for free for us?
I don't know what it's called.
Well, what's it called?
The like public and then student.
This constructor has a couple names. You could call it a no-arg constructor, but more specifically, it's called the default constructor. Right? The default constructor is provided for free, and so you don't have to code it. Right? But if you provide a parameterized constructor, so what? It might look something like this, right? This allows you to, when the object is created, when the object is born, provide the student ID for that student immediately. So this is one parameter in our constructor. So it's parameterized, right? You've got one parameter. Okay, but we're not calling this one. You can see it even says 0 references. In fact, we are calling this one. Where are we calling that one? We're calling it right here. This is a constructor call. This calls the default constructor. All right. Now let me also, because you got a free constructor here, and I just got done preaching about breakpoints. Let's use one. Let's put in, so notice person. Let's put in a breakpoint on my student construct. No, let's go here, and let's just hang tight on my teacher, and I'm going to put a breakpoint in on my student, and let's debug this. And this is again kind of going back to, okay, that happened fast, so I'm going to do this again. I'm going to have you guys watch. We're on line 22. We're calling the default constructor for the student. We're on line 15. That's a default constructor. Notice it does not go into that constructor, nor it's not going to jump ahead to line 18. In other words, before it runs this constructor, notice where the code goes. Oh, what are you doing? Okay, it was just spinning. It had to think for a second. Watch where it goes. Because student is a person, in order to construct a student object, you first construct a person object. So here's the rule. The rule is before the child class constructor runs, it runs the parent class constructor first. And you can see now we are stepping into this person constructor because a student is a person. It doesn't really do anything, but I'm just showing you it runs the parent constructor first. And then it runs the student constructor. See this? It just ran the student constructor. And now we have created our object. So here's the third rule. In inheritance, basically, before the child class constructor runs, the parent class constructor is executed. And you could use the same. Before the child class constructor is executed, the parent class constructor is executed. So it's just, now, that's invisible. Like, you didn't even see that. Like, we've been doing this and you didn't need to see that, but it does matter when you start working with parameterized constructors. Okay? So when you're just working with the default, like, it's completely invisible, and I want to show you when that matters, because right now it doesn't matter. Okay, Vinny?
So is the parent class constructor always going to be on the right of the colon? Like if we have student colon.
Yeah, this is always the syntax, child colon parent.
Okay.
And I promise you that'll be like test questions and that kind of stuff, right? Josh?
Okay, so now my question was, you're probably going to show it, so.
Okay. So let's make a constructor for a person where we can set the person's first name. Okay, so now we have a parameterized constructor for first name. Student is a person. And here's the trick. Well, now how do we make a student that also shouldn't a student also have a first name? Can we do that? Can we set the first name through the constructor? Well, let's do this. String first name, comma, int ID. Now let's create a student. Now here's the magic. And how to get that first name, you do this. You do colon base. Base is a keyword that says call the parent constructor. And so look, if you look here, what does base have? Base has basically two overloads, the null and one that takes the first name. So what this does is I'm going to say, let's go ahead and pass the first name up to the parent. So set the first name, send that up to the parent, and then take the ID and set it to the child's ID. So base, again, so what are we learning here? First thing is first, it's going to execute the parent constructor first, which is base. It's going to pass the first name up to base. You're going to set the first name of the student, and then come into here and set the student ID. So let's follow this flow, but we're not using the defaults now. Student S1 is new student. Now if I take a look, we've got two overloads here. We got one with the first name and an ID, and one with the default. Okay, so let's use this one that takes a first name, Billy, and an ID, 1, 2, 3, 4, 5. Okay, so all we're doing now is creating a student with this constructor. Again, the parent class constructor runs first. If I put a breakpoint in, I can demonstrate that. But we kind of had to tell it what version of the constructor to call with base. So here we go in, notice we go into the student constructor that takes the two parameters. And the first thing it does is it sends first name, which is Billy, up to the parent. So it says send this information up to the parent, first name. Well, that's the one parameter constructor of person that takes in a string. So in comes Billy into this constructor, and ultimately we set underscore first name equal to Billy. You can execute that. Now that the parent class constructor is done running, now we can run the child class constructor, which sets the ID 1, 2, 3, 4, 5 underscore student ID equals 1, 2, 3, 4, 5. And now our student has a first name and an ID. Okay, but we're not, this is just putting the data in, obviously. We're not reading the data out. Yep.
Okay, so do you have to, in the constructor, when you're making a new student, code the first name first because it's in the parent? Is that?
Yeah, so if I look at, no, you could. The only reason that comes first is the order of this.
Oh, so you could put first name last and still have.
Yeah, it could go. You could do int ID, comma, string first name, right?
Okay.
And then all you do here is change the order of these arguments on this side. They're called arguments. And this still works the exact same way. It's just the order of parameters is all that is.
Okay.
Yep. And then this calls you can run into some problems if, like in the child, you start making, I don't know, there's problems that can be had that if you start making these parameterized constructors in the children and you don't have them in the parents, basically, I don't know, you run into some problem. I'd like to demonstrate this problem, but let me take out my defaults. I'm gonna take out my default constructors here. And I'm going to take out this. I'm going to have a way to set the first name here. So all we're left on person, which is the parent, all we're left is with the default because you get that for free. And so now there is no more base with first name. This is still compiling. Okay, maybe I can come back to this at some point, but I think that one of the main things to understand is that the parent is called first before the child, and the way you do that's with the keyword base. But in order for this to work, you got to bring in this constructor in the parent. Okay, so I did come across a bug here. Good, this is what I was looking for. It's like, I know if I play with this enough, I'll find it. I found it. What do we have here? Well, person only has one constructor, which keep in mind, when you write a parameterized constructor, you no longer get the default for free. So if you write a parameterized constructor, you also got to code the default. In other words, you got to bring this in. Yeah, it's weird. I don't know why. I don't know. I don't make it up. That's just the way it works. I don't make the rules. I just follow them. Yeah, if you parameterize a constructor, you no longer get the default for free. I guess the assumption is you know what you're doing. At that point, if you're making a parameterized constructor, you know what you're doing, so therefore you should know that you don't get the default for free. Notice what happens if I don't code a default constructor. Let's kind of bring back this error message. Now I've got, in the parent, I've got one constructor here that says first name. And then in teacher, it says, wait a minute. You got a teacher. A teacher is a person. A person has a first name that you don't have a parameterized constructor for a teacher to have a first name. And so basically what this is saying is you got to make a constructor to set the first name. Well, we know how to do that. Public teacher, string first name, colon base first name. And now all of our errors go away. And again, a teacher could have more specific, like let's say salary, private, double, right? So you could have these fields, in which case then you could set the teacher's first name and the salary. The first name you just pass up to the parent, and then you set underscore salary equals to the parameter that comes in, right?
What if you have more than one thing you need to send up to the parent?
If you have more than one thing, so let's do that. So a person has a first name and a last name.
You did have a first name instead of last name.
Okay, so now we've got more than one thing, yeah? We got a first name and a last name that is our person. We have a constructor that takes both. Yeah, now our constructor takes 3 inputs, and we're just going to pass. If we look at base, again, it's good to look at our method signatures. We only have one. We have one that takes first name and last name. So you would take this first name first, comma, this last name, and just send it up. So you just say base, calling the constructor that takes 2 parameters. Make sense? So now we have a way to set the first name and the last name and the salary for the teacher. Of course, if we go back to student, now this is barking at us. Why is this barking at us? Because it's saying, hey, your parent accepts a first name and a last name, but you're not doing that. So you've got to do that here as well. Something's weird. I'm getting a little bit of lag. Does that answer your question? Right? Commas. Add the comma.
Is it normal that I'm lost?
Well,
I just feel like there's a lot going on. I don't know the flow.
yeah. Well, the challenge around all of this is really have a, and you do, Vinny, you do have a solid foundation. It's just now we're adding on top of it. And so really understanding classes and objects and constructors. For example, we learn constructors. Maybe could use a little more practice with them. You know what I mean? Because in our labs, Billy has a last name too, right? In our labs, we were like doing lists of students and this kind of stuff. But you didn't have to, what is a constructor? A constructor is putting data in when the object is created. We were also doing things like list of students, right? Called AWD students is new list of student. And so we would have a list. If we think about this, what we were doing a lot in our labs, and then we were initializing our data this way. So our first student is a new student. And, well, the new student has the constructor now because we created that constructor. But what if we didn't want to use a constructor? Because I think in our labs, a lot of times we didn't use the constructor. A lot of students I saw were using what were called object initializers. You remember those object initializers? Is to say that you've got these properties and you can set, if we make let's bring back our default constructor. So you know how I'm going to unconfuse you? I'm going to bring it back to what we were doing. Now, why can't we have a default constructor here? Because there's no default constructor in the parent. In order to have a child with a default, you need to have a parent with a default. So I'll bring back the parent constructor. Wait a minute, parent's person. Sorry. There's person. Okay, now that we've got a default no-R constructor here, then our child can have a default no-R constructor here. Therefore, we can use a new student here and curly brace expected. These are those object initializers I was talking about. Now what's not compiling? I got one too many somewhere, so let me clean this up. Yeah, I'm missing a curly. There we go. No. You get lost with the curly sometimes. I know you guys have been there. I've certainly been there.
My existence.
I might.
I figure at this point, there'd be a button that you click and be like, oh, probably wrong one.
Yeah. Okay. What I don't recommend is what I just did, and that's just guess at it until you solve it. That's never a good idea.
That's a lot of this.
Guessing is, I'm telling you, just lining things up and counting them 1, 1, 2, 2, 3, 3, lining things up. Guessing at it, ooh, I'm surprised I got it, but I did get it. Look at the difference. Look at the difference right here. This is creating a new student object using the constructor. But you didn't do that a whole lot. Instead, you were using these object initializers inside of a list. And so, like, here's S1 as a student. If I want to add S1 to the student list, I could do comma S1. And that adds my S1 as my second student. So you can instantiate an object. Here, we'll call it S2 because it is our second student. Like this is an object, and this is adding that object to the list, right? So this is our first student using the object initializer, right? Ultimately, this data is going to go into those private instance fields. And the same with this data here. It's all going into those instance fields. At the end of the day, when you're putting data into a student, it's going into that instance field. And because it's a person, it's going into those instance fields right here. So Vinny, you made a comment that you're feeling a little lost, and I don't know that I got you unlost, other than to point out that what you did last chapter, maybe you didn't use these constructors so much, which is why that might be partially confusing. Because now I'm just demonstrating the constructor and how it behaves. And if you're not used to using constructors, I understand that confusion.
I have a question.
Yep.
So you have to use the constructors when working with parents, working with inheritance?
No, you don't have to.
Oh, like you showed at the beginning, like you can do first name and student ID, like you can code those separately.
Yeah, you could still use those, you could still use these
Okay.
object initializers, like here.
Right.
Yeah. So this is, now is this still using a constructor? Yeah, you're still using the default constructor here.
Mm-hmm.
So do you have to use constructors? Yeah, yeah. In order to create an object, you have to use a constructor. However, you don't have to use, in this case, the default constructor. You can use this parameterized constructor.
Well, at the beginning you were setting stuff like S2 dot first name.
Properties.
Those are
Yeah.
properties.
Yep. Yep. And this right here, this object initializer uses those properties as well. It's just using them at instantiation. Instead of instantiating the object and then changing the properties, we're just doing them both at the same time.
Yeah.
Like,
So
it's-
new student first name equals Billy is S1, and then S2 is just
yeah,
already been defined.
yeah. S2 is this guy right here. Let's take a break. Okay, back from a break. Want to continue on the theory a little bit on this inheritance, and I said, I'd keep it short, which meant an hour and a half, and, we're about halfway through that. I got 45 minutes on the recording, so we're going to keep going on some theory. One thing you might have seen before, if you looked closely at the code on these forms, is that there is this class, is this keyword partial class. Okay, skipping over the keyword partial for now, you got public class form1. Notice form1 is the name of your form. So we're creating this class called form1. Here's your constructor. But notice the inheritance. And you might find out if you hold down the control button, and I'm sure there's other hotkeys of ways to do this, you can actually click on form and see that there's this namespace called forms. Anyway, so all of these classes are in this folder. Let's just call it the forms folder. And one class that's in the form folder. So when we instantiate a form, well, form inherits from a parent called container control. And if I click on container control, I can see there's a parent there called scrollable control. So I'm going up the hierarchy here. You see what I'm doing? I'm just following the parents. And you can kind of see we're getting more generic. Scrollable control is a control. So if I click on control, I want to stop here. Control is a class that if we expand this class, you get a lot of properties and you get a lot of methods in this control class that basically, if you go up the hierarchy on our toolbox, and in our toolbox we have all these different GUI controls. And so ultimately you could view this class of control as a parent to a lot of the controls that we have on our toolbox. And so why is that important? Well, if you can understand the great-grandparent, you can understand all of the children. You know, for example, if you understand that a dog, you know, has 4 legs and some eyes and things like this, then you understand that a Chihuahua is a dog. You can understand the children by understanding the parents. Okay? So all this just to say that in the code that's provided for us, there's a whole lot of inheritance that's automatically going on. And you can dig up that inheritance chain by holding down control and kind of clicking the parents. Form is a container control. A container control is a scrollable control. A scrollable control is a control. Now you're going to notice this comma. We haven't talked about that. That's next chapter. Okay? This control class is just an interesting class because it is the parent of all of the controls on the toolbox. So if you want to understand a lot of the common properties of those controls, you could, in theory, come into this control class and kind of dive down. You can expand the control class. And like yesterday, Cameron Wood, the alumni, talked about going under the hood, right? You understand what's going on under the hood when you're dragging and dropping controls? Like this is under the hood, right? Public class control. And again, some of this is going to be understandable. Some of it, we're probably not at that point where we can understand it. But again, common. Okay. I'm kind of curious how many I have to click up. So you notice a control is a component. We're really getting a generic, I don't know, I have no clue. Marshal by ref object. I wanted to go all the way up the hierarchy because at the end of the hierarchy, at the end of the road, all classes have one parent. At the tip top of the hierarchy, now you'll notice I went all the way up here and it doesn't show any sort of inheritance because there is an implied inheritance, which would be this. The object class is the top of the hierarchy, right? It is the most generic class that everything inherits from. Well, why is that important to understand? It's the same thing I just said. If you understand what's in that object class, then you can understand a little bit more about the children. So if I go into person, and I go into student, for example, right? This might make some sense to you guys. If I come down into here and I've got my S2 student, okay? And if I go into S2, I can do S2 dot. Notice I've got this equals method. Notice I've got this get hash code, toString equals get hash code, get type. I didn't write these methods. Where did I then get them from? Well, you get them from object, right? So inheritance is happening and has been happening for us all along. You've had these different methods that you've inherited in your objects, and we didn't use a lot of them, but you saw them probably. And so, we can kind of talk about like some of the bigger ones. Like I'm just gonna do, like I'll throw a label on this, and I'll do call this label result. Okay, and then in my form, I'll do label result.text equals s2 dot get type. I just want to, now it doesn't like get type. Get type gets the type of the current instance, and it says it cannot convert a type to a string. And so there does look like to be a name property of the type. So let's just see what this does. Debug, start without debugging, and this is all being done. This is all being done in the constructor of the form, so it's just basically it's putting the type of student, and that's pretty obvious. It's pretty obvious that S2's type is student, but it's not always obvious. When you have an identifier, you might not always know exactly. You might not always know exactly what type it is. In fact, it's not uncommon to say if s2.getType.name equals s3.getType.name, right? To seeing if these two objects are at least the same type, right? This is actually quite common when you're talking about an application that might have hundreds of types. And so getType is a useful method that you inherit from object. What else do you get for free? getType is something that you get for free that can be somewhat useful. What else do you get for free because of inheritance? Instead of doing that, let's do label result.text is s2.toString. So you get a toString method. ToString is a method inherited from object. Again, that's the grandparent class of them all. It's like the great class at the type of the hierarchy. The toString, I would say, so what do we have here? This is the namespace, demo 1, namespace like a folder. So the namespace dot student dot class name. ToString kind of out of the box isn't all that useful. Many times, as we've already done in this class, you're going to override that toString. So what is overriding versus overloading? Remember, overloading is another term that's so confusing because we're talking about overriding now. And students get those confused all the time. So overloading, two or more methods with the same name but a different signature, different method signature, meaning different parameters, order parameters, etc. Overriding means giving a method a more specific purpose in a child class. So a child class will override the parent class version of that method. So the parent class being object, and you've got a toString method implementation in object, and we're like, that's not really that useful, so we're going to override it in student, and we would say public override, and notice we get these three methods. We already covered, well, we haven't really talked about those two, equals or toString. Now you know what the keyword base is. Base means the parent implementation of toString, but a lot of times we would just write our own toString here, right? Okay, so you get a toString for free that's not all that useful, so we typically override it. You get a get type for free, and that is kind of useful out of the box. I do like that get type. You also get an equals. It's pretty common to override the equals. So what is the equals method? I have a question for you. To understand the equals method, you should ask yourself, how should I determine if two students are equal? I don't know.
Same ID.
Maybe they have the same ID. If two students have the same ID number, it must be the same student. Maybe you would say maybe the same social security number. I don't know. But I've demonstrated this before, I believe, and the implementation of this method is what you have to do is you have to cast. Ooh, this is really interesting, by the way. Notice our data type here is object. Our data type is object. What is object? Object is the parent of them all. So you can send in a student, and it could be stored as an object. Students can be stored as objects. Children can be stored as references of their parent. If you were confused before, wait till you hear this. Students can be stored as references to their parent. All right? I'm going to have to pick this back up tomorrow. I don't want to, we're really going to go down into the weeds here. Okay? But what I'm doing here is I'm going to convert this OBJ, this identifier, I'm going to convert it into a student. And then what you could do is you could say if this dot student ID double equals S2 student ID, return true, else return false. I just wrote an equals method that accepts a student object, and I basically said if the first student ID equals the second student ID. Now, how would you call this? You might wonder like how this actually works. Here's S2. Here's S3. Notice we're going to give them the same IDs, even though this is Billy Sanders 2 and this is Billy Sanders 1. Okay, but because they have the same ID, they S2 dot equals S3. And this is going to return true or false, so it returns a Boolean. So we need to, get that into a string somehow. Maybe we could do toString. So this is just going to return true or false. This is the syntax for calling that equals method. Notice you do S2 dot equals, and then you pass the other student as an argument. So this equals method returns true or false depending on how you coded it. You get to decide how your objects are equal. Because by default, How do you know if things are equal? We said by their student ID because that's what Ryan said. And so really what I'm looking for this label to say, all this just to say, this should say they are equal. If I run this, I'm expecting the output to be true. And then there you have it. And if I change up my student IDs, it should be false. So what am I getting at here? There's an equals method that you get for free. The implementation of that method is really no good. You want to override it. So what I'm looking at here, it's very common to override toString in your classes. It's also very common to override the equals method in your classes. This is kind of boilerplate stuff. When you get down into it, you're writing custom classes, and it's almost an etiquette, if you will, to provide your thing with a toString and your thing with an equals method. Because other developers, when they use your classes, they kind of expect it, right? It's kind of an expectation that you have a good toString and you have a good equals method. All right, there's one more that you get for free that's kind of trash and it needs to be overridden. Public override get hash code. Now, in the real world, you often need a unique value to represent your entity. So like, if you're a new customer, every new customer should have a customer ID. Something like that. A unique value for them. Okay? Even if you have 100 John Smiths and they all live at the same address. You get what I'm saying? They have all the same values. There should be one unique field. This get hash code should retrieve and return that field. So typically what this is in the real world, this is a database call. So you're storing all your data in a database, and in that database, there's a unique field for your customers. So you're going to read the customer ID out of the database, and then the database is going to return, the database is going to give your application a unique value for the student. You get to decide what that is. Is it the student ID? Is it their social security number? What is it? And then you're going to return that int. Return, I don't know. This would just be some random number. Each random number would be unique for that student. Benny.
So is the hash code auto-generated, or is it what you just said, or it's you put it in? It's the student ID. It's the social security.
It's a lot of times it's a random number type generation, very long, very cryptic.
And the computer does it, right?
The computer does it. Yeah.
Okay.
Yeah. We watched a security video last semester, and they talked about salts. And so a lot of times there's this concept of a salt, which is like a unique, like you generate a random number and then something else on top of it. Point is, it's something generated by the computer, to your question. And this get hash code in the real world application would return that unique value for the student. Okay, so that's all right. I'm going to keep my promise. It's been an hour and 10 minutes of the recording. I'm going to stop here.